Hi everyone, today I will talk about projectile motion and relative velocity. I've got 4 questions for you guys, and I will start with the problems with projectile motion. Here are our first question. So as you can see, there are 3 balls A, B, and C. They are thrown vertically along the x-axis, and the x shows the replacement of the balls, and y shows the height that the 3 balls are thrown. These 3 curves are the track of the 3 balls. So we've got 4 options here, and we will decide which of them are correct. So as you can see in this diagram, that the replacement of A is bigger than the replacement of B and is bigger than the replacement of C. That is, XA is bigger than XB and is bigger than XC. So next I will introduce a formula for this kind of problem, that is y equals to 1/2 a t squared plus v initial t. Because the balls are thrown vertically, so the initial velocity of the ball is just the velocity that is horizontally. So there is no velocity along the y-axis. So for the velocity along the y-axis in this equation, it does not have. So we can cancel this one. And as we can see in this diagram, that the height of B and C are the same. So YB equals to YC. Because the balls are all thrown on Earth, so the acceleration is all gravity. It's 9.8 meter per square second. So they are the same. They are the same. So we can see in this equation that TB equals to TC. So in this way, this equation becomes true. So TB equals to TC. And as we can see in this diagram, that the height of A is smaller than the height of B. The acceleration for the ball A is still 9.8 meters per square second. To make this one become true, we have to let TA smaller than TB. TB is time, so they have to be bigger than 0. So now we get that TA is smaller than TB and equal to TC. So back to the 4 options. A is incorrect because TA is smaller than TB. And B option, TB equals to TC. Well, it's true. So next come to the option C and D. For option C, VA smaller than VB. Because we know that XA is bigger than XB. So we know that VXA times TA is bigger than VXB times TB. And TA is smaller than TB. So how can we make this one come true? We have to make VXA bigger than VXB. Otherwise, it won't become true. So we can see that the option C is incorrect. And for option D, because XA is bigger than XB, so V0B can become XB divided by TB, and VOC can be XC divided by TC. From this one, we know that TB equals to TC. And from this one, we know that XB is bigger than XC. So the things that XB and XC are divided by are the same, but XB is bigger than XC. This means VOB is bigger than VOC. So the option D is correct. So for this problem, we know that B and D are correct. So next, we will come to our second question. At what initial speed must the basketball player in this diagram throw the ball at an angle of 55 degrees above the horizontal to make the full shot? The horizontal distance D1, this one, is 1.0 feet, and D2 is 14 feet, and the height H1, this one, is 7.0 feet, and H2 is 3.28 10 feet. Now I've changed all these feet into meters by this conversion factor. So how can we solve this? Well, we know that the speed V0 can be transformed by this. The speed at the y-axis and the speed at the x-axis. So, because we know that theta is 55 degrees, so we can denote Vx as V0, this one, V0 times cosine 55 degrees, and Vy, we can denote it as V0 times sine 55 degrees. We know that x equals to V0 times cosine 55 degrees times t is this one. This is Vx. Vx times t becomes x. The displacement of this question, in other words, d2. And the x in the y-axis equals to V0 times sine 55 degrees times t minus. Why this is a minus? Because g is the acceleration is downward, so the acceleration is the inverse of the is inverse of the positive one. So this comes from the formula that x equals and the displacement in the y-axis, this one, is h2 minus h1. The displacement. It means the final position to the initial position, the height of between them is h2 minus h1. So we've got the equation, and we can solve this one and get the answer now. Okay, next for the relative velocity. Here is our problem. So you can read it by yourself. So the swimmer, she wants to swim just 0.45 meters per second to the seashore, but the water flows at 0.40 meters per second. So, as we can know, if we want to get the relative velocity of the girl respect to the seashore, we have to do this. Velocity the girl respect to the seashore equals to the velocity the girl respect to the water plus velocity of water respect to the seashore. So how can I solve this one? We have to draw a diagram, and the arrow of this the end of this first arrow must be the start of the next arrow, and the relative velocity is the arrow like this. We also know that this one is 75 meters because the speed that the girl moves in this direction is same as the time that the girl move in this direction. So we can use these two factors to know the time of the swimmer, the girl. And then we got this time t, and we times it with the velocity in this direction, and we know that how far the girl is from where she land, and how long it will take her to reach the other side. Well, we have already calculated it. It's just the time t, and we've solved the problem. It's simple, right? So for the last question, you can read it by yourself. In this time, the velocity the passenger respect to relative to the water equals to the velocity that the passenger respect to the boat plus the velocity that the boat respect to the water. And as I said, we draw a diagram to solve this. And I've also said that the arrow of the end of the arrow of the first factor must be the start point of the second factor. and now we line them. End to end to the end of the second vector, the last vector, and the start is exactly where the first vector starts. And now we calculate the velocity of this one. Because this angle is 45 degrees, we can also know that this angle is also 45 degrees, and we make this line perpendicular to this one, and with this 45 degrees we can calculate the velocity of this one, and also the angle this velocity to the horizontal line. So that's it. Thanks for listening.